1 of the module on principles and methods of teaching senior high school physics. And you are once again welcome to session 3 of this unit. And in this session, we'll be looking at the purpose, goals, and objectives of instructional theory. My name is Patrick Ejay. Now, at the end of this session, you should be able to explain the term scientific literacy. And secondly, explain why translating scientific literacy into goals of knowledge, skills, and values of curriculum and instruction is an important process for science teachers. So let's look at the purpose, the goals, and objectives. And as science teachers or physics teachers, we must understand that in the science class, it's more or less like embarking on a journey. And in every journey, you must have a destination. So in your destination, the main question is, what are you going to do? What are you going to achieve out of this journey? So in the science classroom, we have students. And in the journey, that is in our teaching journey, how do we perceive our learners? What kind of learning experiences are they going to encounter? What kind of learners are we going to produce after these students have gone through the set of instruction? And so the term scientific literacy expresses the destination for all our students, the kind of learners that we want to produce out of the school system after going through the set of physics instruction. And translating this scientific literacy into goals of knowledge, skills, and values of curriculum and instruction is very important for the science teacher, because the translation has to be fairly consistent with the overall purpose. So what are we trying to say? What we are trying to say here is that we know that it is the role of the teacher to translate or ensure the translation of curriculum goals and objectives into learning experiences that will be acquired by learners. And these learning experiences is what is going to make our students science literate. And so in as much as we are ensuring that our students acquire the best form of these learning experiences, we must ensure that these learning experiences are also consistent with the overall goals, the overall aims of our educational system. And the specific objectives of lessons have to be consistent with the purpose of developing scientific literacy. So we know that the specific objectives are more or less breaking down the general goals of education into simple bits that will be given to our learners within particular periods of time. And so these objectives must also be in line. It should be consistent with the general purpose of our educational system. And as science teachers, we must continuously re-examine the goals and objectives of our program here of science, of physics. And when we are doing this re-examination of the goals and objectives of the science program, there are some questions that we must ask ourselves. Some of such questions include: which units will I teach this year? What new topics will I introduce? Now, your ability to provide answers to these questions will now form the basis for the revised goals and changes in the science program. And there are clear distinctions between goals and objectives. We know that goals and objectives are not the same, although they look similar. However, they are not the same. So goals are broad statements that give a general direction to science curriculum and classroom instruction. So one thing is that although goals and objectives look alike, goals are broader than objectives. And the disadvantage of a goal is that they are too broad for specific direction concerning a grade level, concerning the science subject, concerning the personal aims and preference of science teachers. And it is necessary as a teacher to reformulate these goals into objectives that are appropriate for each science teaching. So although goals and objectives differ, Biologically, they are related in that objectives are derived from goals. So note that objectives depend on goals. Out of goals, we are able to come out with our objectives. Now, what are some of the basic goals of science education? And we must understand that there are many goals of science teaching. And for a goal, it should be comprehensive enough to include the generally accepted aims and objectives of science teaching. And goals should be understandable for other teachers, administrators, and parents. So anytime we take a goal, when the teacher takes it, the teacher must understand it. The administrators at the school level, as well as parents, must know what exactly the goal of physics learning is. And also, goals should be neutral. That is, it must be free of bias. It must not be oriented towards any particular view of science teaching. And goals should also be few in number. They should differentiate concepts and abilities. Goals should be easily applicable to instructional objectives. All these are basic goals of science education. And so for the science education or for science teaching and learning, the various goals that we present should be able to differentiate between the various concepts and the ability levels of our learning. So, what are the objectives for science teaching? Now, we made mention that objectives are specific and they also depend on goals. And so, because they are specific and they depend on goals, then they should be specific in such a way that they can give the teacher a clear direction for planning and evaluating the science instruction. And objectives should also be understandable to the students, the teachers, administrators, as well as parents. So all these stakeholders in the education system must understand the objectives of the science instruction. And science objectives should also be few in number, but they should be comprehensive for any lesson, a unit, or program. So once we state specific objectives, when it comes to dealing with that objectives, we must deal with it comprehensively so that learners will be able to acquire all the experiences that we want them to get out of that unit or lesson. And science objectives should also be challenging, yet they must be attainable for your students. So we are not using the word difficult here. We are saying it should be challenging. Although they are challenging, they should be attainable, they should be achievable by your students. And science objectives should differ conceptually from each other. So every objective that will be stated, we must ensure that when it comes to conceptual level, knowledge, understanding, application of knowledge, the various skills, these objectives should be able to identify all these key concepts so that when the learner having gone through this set of instructions, we can be able to identify the various kind of changes that has occurred in the life of the learner or the behavior of the learner. And science objectives should be appropriate for the subject you are teaching. So you are teaching physics, and for that matter, the objectives that you state for physics must be appropriate for physics. Now, what are the types of objectives for science teaching? And objectives can be stated in terms of instructional or learning results. So it means we have instructional objectives as well as learning objectives. Now, the emphasis here is that in instructional objectives, the emphasis is on the teacher. That is what the teacher will do in the teaching learning process. And the learning objectives, the emphasis is on the learner. That is what the student will do. Now, when we state instructional objectives, one advantage of such an objective is that it gives the teacher a sense of direction during the teaching learning process. But the disadvantage is that the teacher may not be clear as during the teaching learning process. Now, again, objectives can also be classified as either behavioral objectives or non behavioral objectives. And when we talk about behavioral objectives, this type of objective states how the student will behave as a result of instruction. In other words, the kind of observable changes that we must see in the behavior of the learner after going through a set of instructions. And these behaviors must be an observable indication that learning has occurred. So, the various changes in behavior that we see also gives us an indication that learning has occurred in the learner. And these are some examples. So let's look at these examples. The student should be able to identify components of an electric circuit, describe the relationship between resistance of a conductor and the current passing through it. Now let's take note of the action verbs that were used in these two examples as we look at non-behavioral objectives. So, for non-behavioral objectives, let us look at this example. The student should be able to learn the parts of a hygrometer, understand the concept of movement, know how to use the electronic microscope. I hope you have taken note of the various verbs that were used in stating these two objectives. Now you realize that in the non-behavioral, to state an objective such as the student should be able to learn, the student should be able to understand, the student should be able to know. To what extent must the student know? To what extent must the student get an understanding for us to say that learning has occurred? Unlike the behavioral objective, which is stated in measurable terms, so identify the parts of an electronic microscope. And this becomes measurable. This becomes more specific. So we must understand that anytime we are using a verb such as learn, understand, know, then it means we are talking about non-behavioral objects. And it is very important, like we mentioned, to note the action verb in each stated object. Now, students, in this session, we looked at goals, purpose, and objectives. We also saw the goals for science learning as well as objectives for science learning. As we bring the session to an end, take this as a take-home. Explain the difference between instructional objectives and learning objectives. Get your answer for presentation in the next.